Welcome to the Podkey summary of Run Local Agentic AI on the Mac using MLX from WWDC 2026. A lot of this comes down to one idea. The whole AI loop can now live on your Mac, not half on your machine and half in somebody else's cloud. That means the model can think, use tools, look at results, and keep going until the job is done, while your data stays local and you stop worrying about API keys and metered usage. Under the hood, Apple Silicon, the MLX stack, and some pretty serious batching and distributed inference tricks are what make that feel practical instead of theoretical. The useful mental model here is simple. User, then agent, then model, then tools, then back to the model, over and over until the task is finished. So instead of a one-shot prompt where the model spits something out and hopes for the best, it can iteratively decide what to do next based on the tool results it just got. That's what makes agentic workflows feel more capable in practice, especially for things like code work, repo inspection, or any job where the first answer usually shouldn't be the last answer. And if that entire loop runs locally on Apple Silicon, all of the data stays on the Mac, which is a big deal for privacy and honestly a relief for anybody tired of juggling cloud credentials. The stack starts at the bottom with MLX itself, which handles metal accelerated array operations and memory management built specifically for Apple Silicon. Then MLX LM sits on top of that and adds the more model-facing stuff: loading models, quantization, and an OpenAI-compatible server. That server matters because it supports structured tool calling and step-by-step reasoning. So it's not just hosting a model, it's hosting a model in a way agents can actually use. And because it follows the standard chat completions protocol, existing OpenAI-compatible agents like OpenCode, Pi, or custom scripts can connect without needing surgery first. That's one of the quieter advantages here. If your tools already speak OpenAI-style API, switching to a local stack can be surprisingly low drama. On the hardware side, the M5's dedicated neural accelerators make matrix multiplication 4 times faster than the M4, and that directly speeds up prompt processing kernels in MLX. In plain language, the model gets through the reading part faster, whether that's a code base, a long context window, or a pile of tool output from an agent workflow. MLX automatically picks the best kernels, so developers can see up to a 4-fold reduction in that processing time without changing their code. That kind of improvement is the nice kind, where you don't have to become a kernel expert just to enjoy it. There's also a really practical performance piece around concurrency. MLX LM Server uses continuous batching, which means incoming requests get grouped together dynamically so multiple subagents can be processed on the GPU at the same time. Even better, new requests can join an ongoing batch, instead of waiting for one batch to fully clear before the next one starts. That avoids the stop-and-go feeling you get with queue stalls, and it keeps a multi-agent system feeling responsive instead of weirdly polite and slow. If one Mac isn't enough, MLX can also shard a model across several machines connected over Thunderbolt or Ethernet. With macOS 26.2's Thunderbolt RDMA, the machines can communicate with low latency and high bandwidth, which is exactly what you want if the model is split across nodes. Benchmarks show up to 3 times speedups with 4 nodes, and that acceleration helps both inference and prompt processing across the cluster. So this is not just a storage trick for giant models, it's also a way to make the whole system move faster. The flashy example here is DeepSeek's 1.6 trillion parameter model. That model needs more than 800 gigabytes of weight memory, which is way beyond what a single Mac can hold. By distributing the model across multiple machines, MLX makes it possible to run something at that scale locally. That expands the ceiling quite a bit, because now local isn't defined only by the limits of one box sitting on your desk. This gets especially tangible in Xcode. In the intelligence settings, you can add a locally hosted chat provider that points to the MLX server's port, and then the IDE can talk directly to your local model. From there, the model can inspect, build errors, suggest targeted fixes, and apply code changes without you bouncing out to a browser tab or a separate app. And because it's local, your code stays private, which is one of those benefits that sounds obvious until you remember how much sensitive code people routinely paste into tools. The other reason this feels less niche than it might sound is that the ecosystem is already there. Tools like Ollama, LM Studio, and VLLM already rely on MLX. So a lot of users are benefiting from this Apple hardware acceleration, whether they've thought about the plumbing or not. And because MLX LM Server mimics the OpenAI API, existing agent frameworks can move to a fully local stack with minimal configuration changes. That compatibility layer is doing a lot of work here. It lowers the friction between interesting demo and something people will actually use. The big picture is pretty clear. Local AI on Apple hardware is getting faster, more agent-friendly, and a lot more scalable. When the same setup can keep your data on device, plug into existing tools, and even spread itself across a cluster of Macs, it starts to feel less like a workaround and more like a real platform. Which is a nice place to end before somebody decides their desk needed 4 more Macs and a Thunderbolt spaghetti situation. This episode was generated by Podkey. Create your own at podkey.fm.